This is your reality check.
Welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. Today is April 9th, 2021, and I'm producer Pat. As I mentioned a few weeks ago, the crew is currently facing some challenges in keeping our regular show schedule, not the least of which are new stay-at-home orders in Ontario and a curfew in Quebec where Adam is. That said, we're working on segments and should have a new show for you soon. In the meantime, we wanted to rerun an interview from a few years ago that Adam and Darren did with Dr. Kim Hellemans about the neuroscience of addiction. I hope you enjoy it and that everyone out there is staying safe and healthy, and we will talk to you soon.
Hi, Kim. Thanks for being here.
Thanks for having me.
Now, Kim is teaching faculty and current chair of the Department of Neuroscience at Carleton University, and she also happens to co-host a podcast called Minding the Brain with friend of the show, Jim Davies.
Great podcast.
I paid them to say that.
There you go. Now, as I said, our main focus today will be the neuroscience of addiction. And as usual for the listeners, at least this is my approach, I'd like to start with some broad but important concepts and ideas, and then that would enable a more detailed discussion. So when we think about addiction, I think many of us think it has something to do with some sort of reward mechanism being stimulated. But let's start with the basics. Kim, why do people do anything?
Oh my, that's a big question. I feel like, do we have enough time? So why do people do anything? I think certainly this is an idea that is not a new one, nor probably has it been one that hasn't been talked about on this podcast before, but it speaks to really basic motivation, right? As humans, really our hardwired nervous system is there to do two things. Number one, to approach things that are more likely to enhance our survival. Mm-hmm. And number two, avoid things that are likely to challenge our survival, right? So we avoid the threats, we avoid poisons, we avoid potential animals that may cause us harm, and we approach things like food sources and potential sexual mates because they are going to be likely to enhance our survival. So really, fundamentally, it boils down to the fact that our brain was adapted into an environment that our ancestors would have favored approaching these sorts of things like food sources and specific food sources and avoiding other things.
So when we engage in those behaviors, is the brain sort of giving itself certain happy chemicals to make sure we do those behaviors? Yeah,
that's a great way of saying it, for sure. What happens is that anytime we engage in those pleasurable activities, the reason that they are pleasurable, again, they enhance the likelihood of our survival. So when we eat tasty food, what happens is that one of the main systems in the brain, the main circuits that's activated is what's called the mesocorticolimbic dopamine circuit. So
that's why we have a neuroscientist on.
Nice.
Yeah, and which every time I say that for my students, their eyes kind of like, oh.
Let's actually break it down. So
meso means middle.
Yep.
Cortico means cortex. Limbic means the limbic circuit, which is the main circuit that's involved in motivated and emotional behavior.
Is that also thought of like the earlier brain in our
Yes, correct. Yep. Okay. So there's actually a phylogenetically older cortical layer that is beneath the cerebral cortex that is part of the limbic circuit. So
phylogenetic being a fancy word for the history of the development of life?
Correct. Yes. Yeah. And ontogenetic is the history of the human.
Yes.
Yeah.
Phylogeny recapitulates ontogeny.
Oh, I love that statement. No, yeah. Ontogeny recapitulates. Yeah.
Please write in if you got it wrong like I did the first time.
Yeah. Please send all comments and criticisms to Darren McKee.
Exactly. Care of Adam Gardner at the Reality Check.
Oh, boy.
So the mesocorticolimbic dopamine pathway, which for many years was the dominant addiction neuroscientist, really focused on this mesocorticolimbic dopamine pathway because it literally is the main circuit that seems to be activated whenever we engage in pleasurable activities such as food, sex, drinking, etc. And so essentially what happens is that we activate this pathway and dopamine is released in some key neural regions. The main one is the nucleus accumbens. And so the nucleus accumbens is a tiny little nucleus in the brain that is essentially every time dopamine is released into the nucleus accumbens, it translates to the subjective sensation of pleasure. Another output of that pathway is an area known as the hippocampus. And the hippocampus, it does a number of things, but in this context, we'll say that what it does is it says to the organism, remember the place where you engaged in that pleasurable event, because if you need to plan for it in the future, you need to know where to go. So the hippocampus is one of the targets. And then the cortex. And so the cortex, as I'm sure you and many of your listeners are aware, is that the outermost layer of the human brain that anytime information reaches the cortex, the individual is conscious of that. So when we send information to the cortex, it's basically saying, particularly pleasurable events, remember this, pay attention to it, because the next time you're hungry or you're seeking a sexual mate or you're thirsty, now you can plan for it in the future, because our cortex, in particular the prefrontal cortex, is our time traveling device.
Cool. So that sort of sets up how the brain rewards itself in certain ways to encourage certain behaviors. And how does that segue to addiction? How would you define addiction?
Well, I'll start out by saying that there's actually no agreed upon definition of addiction.
What? That doesn't sound like science.
What? Scientists can't agree on this?
Well, do some of them have a cortex and some of them don't? Why? What's the root cause here?
Which makes me think of something I saw in the news today. Scientists agree coffee and naps are better than coffee or naps separately.
Oh, yeah, that sounds right.
It's A, it sounds right. And B, scientists are agreeing on this? What? That's news.
Only 80% could agree on toothpaste, so this is revolutionary.
Okay, so back to addiction. Scientists, clinicians, medical physicians, nobody can agree on a definition of addiction, but the definition that I actually take from Robert West, who wrote a book called Theory of Addiction. And he defines addiction as a loss of control over a reward-seeking behavior. Oh. And that speaks to two things that I think are really crucial, and speaks to the underlying neurocircuitry that becomes pathophysiological in addiction, which is that it's that reward-seeking behavior that's become a main focus and preoccupation, and the loss of control. So in addiction, most individuals who have addiction will report that they feel this compulsivity towards seeking the drug, taking the drug. And even though there's kind of that sense of, I know I shouldn't be doing it, in spite of that, individuals will persist, and they'll say that they literally felt like they wanted just one drink, but they lost control, and next thing they knew, they woke up and they'd had another bender. So that's what I would say is a good definition of addiction. When we look at it in the brain, what I like to say is that addiction, for a substance to be addictive, and we can talk about behaviors later, one of what I would say is the important criteria is, does it actually increase firing of that mesocorticolimbic dopamine pathway? And importantly, does it do so in a way that's above and beyond normal, right? So we see food and sex and other natural rewards that activate that pathway. But when you consume things like heroin or cocaine, what I always say is that with broccoli, you're going to really release 10 units of dopamine. With crack cocaine, it's more like 10,000 units. Right. So how can the nervous system compete with, and the organism, with understanding that food and sex and other natural rewards are important in the face of that 10,000 units?
Right. Or even if you had broccoli with crack cocaine, 10,010 is hard to beat. It's interesting, and of course it makes a lot of sense that different disciplines would have different definitions. And what I liked about what you just said is it's a combination of sort of a subjective experience and neuronal circuitry. The one I'm most familiar with is just something that interferes with normal function in your life. And I think it's a bit of a broad clinical definition.
I think that's too broad.
Too broad. Fair enough. Do you think there are other circuits involved?
Yeah, so the mesocorticolimbic dopamine pathway was the main target of interest for scientists that were studying addiction in the 1980s, 1990s. Up until the early 2000s, there was emerging research that has demonstrated that, in fact, it's not just about dopamine. And it's been a very dopaminocentric field for a long time.
Big dopamine, eh?
Big dopamine. And now we realize that, in fact, opioids seem to be perhaps even more implicated in the subjective sensation of pleasure. So just as we activate dopamine pathways when we engage in natural rewards, such as food or sex, there's also activation of your natural opioid systems, the endorphins. So we're actually releasing these endorphins, which function to also, interestingly, further activate dopamine. So the opioidergic system seems to be implicated as well. And also what I should mention is that when the brain is challenged by substances such as alcohol or cocaine, which activate these reward systems, we say that it's challenged the hedonic homeostasis of the brain. So hedonics, pleasure, homeostasis, steady state. And the brain is a highly plastic and adaptive organ, and what it wants to do is maintain homeostasis. So when the hedonic balance is challenged by activating these reward systems, such as dopamine and opioids, the brain in turn will activate compensatory mechanisms to bring down the hedonic state. And so this is the so-called anti-reward circuits. So the anti-reward circuits involve a different set of brain structures, including parts such as the extended amygdala, it's called, as well as the bed nucleus of the stria terminalis, and then also parts of the hypothalamic pituitary adrenal axis. So lots of
Don't talk down
brain circuits, lots of big words, and basically that pathway just is calming down the nervous system. It's saying too much, too much, too much. But now, then you can imagine that those circuits are active, then the drug is now metabolized and excreted from the body, and what you have is an unmasking of that anti-reward circuitry, and that is withdrawal.
Do these compensatory mechanisms kick in immediately as you're taking the drug, but then only reveal themselves once the drug is so-called metabolized?
That's an excellent question. And in fact, there's a group of scientists out at University of California, San Diego, that have really, George Koob has spent his entire career looking at this, and he has suggested that over time, with repeated drug exposures, in fact, that onset of the anti-reward system the latency becomes shorter and shorter and shorter, right? So initially, you can see, like, you can imagine it as a set of curves where the hedonic response starts and goes up to a peak, and the anti-reward system starts after a short amount of time and reaches a peak and goes down. Over time, with repeated drug use and what it would be marked as addiction, is you have the latency to that anti-reward system is shorter, the peak to the hedonic response is lower, and the peak to the anti-reward system is higher, and so on and so forth.
Taking more in a shorter
that's
period
right.
of time.
So there's tolerance, right?
So you enjoy it less, but you want it more.
Correct. That's
terrible.
That's a beautiful definition of addiction. And people will say they like it less and less, but want it more and more, which is what was the basis of one of the other major theories of addiction that said it's because they want it less and less, so they want it more and more, and they like it less and less. Liking, if that's really dopamine, right, then we should see, in fact, dopamine going down, and that's not the case.
Now, would you say that anything can be addictive, or are there certain behaviors or substances that just are kind of immune to it?
So back to what I would say is a criterion for something to have an addictive potential, I would say it needs to have some activation of that mesocortical limbic dopamine pathway and also the opioid system. So it has to be, for something to have addictive potential, I would say it needs to be coded in the brain as being pleasureful. Now, you can imagine there's a lot of individual experience with that, right? So I like maybe running. Somebody might find that that's torture. Somebody likes playing hockey. I personally think that is torture, right? So there is a little bit of individual differences. Now, that's not the only piece, because obviously, and this is argued and debatable, can running become addictive? It's a positive behavior. There are some people who certainly show compulsive exercise behaviors, but the behaviors, so we can talk about that later, but Substances, exogenous substances, need to activate that mesocortical limbic dopamine pathway. So antidepressants, for example, even though they activate the brain, they have an effect on the brain, they don't activate the reward pathway. Therefore, they cannot become addictive.
Yeah.
Right? It's not to say that they won't show tolerance or withdrawal.
Yeah.
Those are separate. So with behaviors, kind of the same thing. It's the behaviors that I would consider that could become addictive are those that very potently are activating that reward pathway.
Yeah. I've heard concepts such as physical or mental addiction. Do these terms really mean anything? And does it bear on how addictive something is? Is there a fundamental difference there?
Right. So, I've heard physical, mental, physical, psychological. I personally don't like those terms because as a neuroscientist, I would argue that your physical self is your mental self, right? My neurons are literally what I would say your brain is producing the mind, right? That cognitive experience of self. And ergo, that is the mental or the psychological. But I see where people are getting at. I think there are certainly what I would say is that there is a physiological change in the neuronal pathways, right? So with addiction, you see circuit changes. Yep. You don't see cell death or neurotoxicity, which is what a lot of people tend to think of when addiction is marked by like it kills your brain cells, which is actually false. But there are circuit level physiological changes in the brain, which then is also coupled by behavioral cognitive changes. But the behavioral cognitive emotional changes are a result of those physiological changes, right? So you wouldn't necessarily see one without the other.
So I was wondering about that, if thinking of the case of people who might suffer from obsessive compulsive disorder, and there, at least it's hitting on one part of the definition of addiction, where someone's doing something they don't want to do, but then you might say, but it's not activating a certain neural circuitry, so it doesn't count. Is that correct?
Correct. So there are a lot of overlapping features to obsessive compulsive disorder and substance use disorders, primarily of that compulsive piece. And one might argue that the obsessions that you see in OCD are similar to the preoccupation that you see with addiction. But again, the underlying motivational states are different. And OCD, it's around reducing anxiety. So we have a negative reinforcement aspect, whereas addiction is marked by both positive and negative reinforcement. You do something because it makes you feel good, and then eventually over time you're doing it to alleviate that horrible state of withdrawal. In addition, when you look at the brain circuitry, circuits that are activated with obsessive compulsive disorder and substance use disorder, there are some overlapping pieces, primarily in the prefrontal cortex, but they're not identical.
Right. And then I think just to add a bit of a nuance, not that you were implying it, but just to clarify, that I think because, like you, I agree that the mind is what the brain does, and we are various versions of our neuronal selves, we may be in conflict, meaning that people who do suffer from addiction, you said they're getting the reward, something that's pleasurable, but even in the moment in which they're engaged in it, they could also be disliking it because they do feel compelled in a certain way. So I'm just thinking that someone is seeking something which is bringing pleasure, quote unquote, neurochemically speaking, but there's a different part of them, a psychological, subjective experience, which is like, I don't even want to do this. But part of me is driven to do it because I need the fix.
Yeah, I feel like suddenly we've tread into dissociative identity disorder, but that's all good. But I do want to also emphasize that over time, and this is something that you hear anecdotally from individuals that are living with an addiction, that they used to take drugs or engage in that behavior in order to feel good, and now they're just doing it to feel normal, right? So there's other theories that suggest that addiction in the early stages is marked by impulsivity, and in the later stages is marked by compulsivity. So that impulsive compulsive switch may be marked by the changes in certain brain circuits that become dominant in the later stages of addiction.
Right. And humans like rhymey things, so it sounds more true. Impulsive and compulsive. It must be true. I think you've sort of touched on it, but do you think there's a fundamental difference between a chemical which affects the brain from something like alcohol or tobacco and something like from a behavior, could be gambling or video games? Yeah,
so this is a question that I get asked a lot, and it's one that I actually put forward in my course. I teach a fourth year course called The Neural Basis of Addiction, and I run the course as if it's like a giant theory. And my hypothesis at the beginning of the semester is these are the brain circuits that we see that become, that are implicated in addiction. let's go through every single major drug class and how do we see those changes in chronic alcohol, chronic nicotine, chronic heroin or opioid use. And because even though every single substance in the that is quote unquote addictive works in a very unique way in the brain, they all obviously converge on common pathways because the overall behavioral state of addiction is pretty unitary. I mean, even though there might be subtle differences in how the symptom profile, but what we know of as addiction is one thing, right? So even though nicotine works different than alcohol, which works different than marijuana, for example, they all converge on that mesocortical limbic dopamine, the opioid pathway, the anti-reward pathway, and then what I focus on in the later stages is the preoccupation anticipation phase, which is mostly the prefrontal cortex. Now, each of those drugs activates those pathways differently, but we do see common changes in them throughout with each of these substances. Now, the question is, then how is gambling addictive, right? Because it's not directly modulating or having a target in the brain, right? So opioids, obviously things like OxyContin and fentanyl target the opioid system. Alcohol, we don't know how it works in the brain, but we think it influences GABAergic firing, which is an inhibitory neurotransmitter. Nicotine targets the nicotinic receptor. Marijuana targets the cannabinoid receptor. So some of them directly target dopamine, some of them indirectly. The best case scenario the way to explain this is that not everybody who uses a substance develops an addiction. And I want to quote one of the top scholars in the field of addiction, doctor by the name of Dr. Gabor Mate, who is a medical physician. I'm not sure if you've heard of him.
Yeah, no, he's excellent.
Yeah, he is. He's written the book In the Realm of Hungry Ghosts. And he said, in order for an addiction to happen, you need three things. You need a susceptible individual, you need a drug that has addictive potential, and stress. And that's really what I want to focus on because we're beyond the 1980s, that drugs they're addictive. If you take them, you will become an addict. And I don't like to use that term, but that was the term.
Don't use drugs.
Yeah, that's right. This is your brain on drugs, etc. That I want to focus on that vulnerability piece, right? Because really that's the important thing, is that there are individuals that are more at risk for addiction based on their early life experiences and their genes, right? So there's genetic and epigenetic factors that what we now think is that those key neural circuits that are targeted by drugs of abuse are already altered, right? So then you layer on top of that the experience of drugs, and these individuals, and there's one of the major theories that says that these individuals are self-medicating low levels of reward already, then it takes them to those other levels. And then so imagine you've got somebody who has all those risk factors, and then you give them something like McDonald's, or you take them to a casino. So these are salient, rewarding events that if somebody who has already a vulnerable nervous system, this could then be coded in the brain as very potent. So it's not just about the reward, it's about the appraisal of that rewarding event, right? So that's why it's not just about dopamine.
Right.
Dopamine will go up, but it's also about parts of the prefrontal cortex, such as the orbital frontal cortex, which appraises and assesses and evaluates that reward and compares it to everything else that that organism or that individual has previously experienced and said, does that compare to going to school? Does that compare to my dull girlfriend that I've been dating and having sex with for the past 8 months? No.
So I guess a follow-up, I was curious, and I talked to you about this before, is whether like heroin is addictive, and then there's also a question whether like chocolate's addictive or sugar's addictive that people say. That's just the wrong way to describe substances. That's at point one. Or you'd almost have to look at a distribution for the population of interest and how many people are more likely to be addicted to it than not. I guess what I'm trying to say is broccoli doesn't seem to be addictive, although maybe someone out there is. And then cocaine is going to be more addictive for more people, even though many people could probably take it and not become addicted. So I'm just sort of imagining some weird probability distribution for all substances.
Yes.
Doesn't indicate addictive, not addictive, but more a distribution that, 30% of the population we looked at are more likely to become.
Yeah, and people have done that. So David Nutt is a British scholar that has looked at addictive risk and addictive potential. And he's also looked at how certain, in particular, substances may be more or less harmful. And he plots them on these interesting distributions to say which ones, based on their harms to themselves or to the broader society, their costs, and then again, like how likely somebody is to develop an addiction. So you have this really neat kind of 3D map, and heroin is certainly a nicotine.
That's delightful. You come up with an idea which seems like it's new to you at this moment. Like someone spent 30 years looking at it.
David
actually, don't feel badly. It's like good. Someone's doing this already.
Well, it also means that you have good ideas.
Oh yeah,
right?
sure. So I guess to ask the question, what do you think is the most addictive substance? Is that a meaningful question?
I think so, because I do think there are certain substances, exogenous substances, that have more addictive risk. And also, we need to take into consideration how those substances are consumed, right? So, for example,
I was going to say, give us one or two, and then how they work.
Snorted cocaine is less addictive than smoked cocaine. The reason for that is based on pharmacokinetics. And pharmacokinetics is essentially how the body interacts, the drug interacts with the body. And what that means is how quickly the drug is absorbed and distributed to its target organ. In this case, it's the brain. So when you snort crack cocaine, it's absorbed via your mucous membranes, which is actually a very slow way of absorbing a drug. And then once it's absorbed into the bloodstream, then it's distributed up into the brain, because the brain is a hungry organ and wants all of your blood and oxygen and glucose. By contrast, when you smoke crack cocaine, the lungs are a rich surface area for absorption, and therefore the absorption is almost instantaneous. So people who smoke crack cocaine will report they are instantly high. So if you imagine, the blood levels are peaking very quickly and then metabolizing quickly. So it's promoting more binge use. So the pharmacokinetics, coupled with the pharmacodynamics, which is a fancy word of saying how those drugs act in the brain, are what can determine the addictive potential of a substance.
Would there be a comparable example between edibles and smoking marijuana?
Correct. So edibles are similarly slower absorbed because when you consume cannabis edibles, the absorption is enhanced, by the way, if you add oil, which is why people will make pot brownies, because there's lots of oil in there and it enhances the absorption. But when you eat edibles, what happens is that the cannabis is subject to what's called first pass effect, which means that most of the substance is metabolized by the liver before it gets up into the brain. So peak absorption after consuming edibles is between 30 and 60 minutes. Whereas when you're smoking, it's more like 15. Right,
so just put a gummy bear under your lip, what's going to happen?
It's like
it depends how quickly it dissolves.
An hour, yeah, exactly. That's like the real slow burn, right? So that can actually be quite dangerous. I don't know if you know, like taking edible, not dangerous, but you can be like, I'm not getting anything, and you just keep eating, and then suddenly, boom, you're so stoned.
It's like someone drinking and takes one drink, and 10 minutes later they're not feeling it.
Yeah. Correct. Yeah. So smoked cannabis is more addictive than eating cannabis. Yeah.
Now, with regards to marijuana specifically, there's been some controversy on the age of use. Now, here in Canada, some health experts are arguing that there should have been a minimum age of 25. Why is this? And in general, are children simply more susceptible to addiction, or is there something specific about marijuana here?
So the age question is one that comes up a lot with addiction in general, and not just with marijuana. And it relates to the fact that really the brain is continuing to develop well into early adulthood, right? So in terms of brain development, you have, neurogenesis, the cells are born, they migrate to the part of the brain where they're meant to migrate to, and then they start differentiating, and then they grow their little synapses and branches, they branch out. The last part of neurodevelopment is myelination, right? So you're refining all those connections between cells, and in particular, the very last part of the brain to have myelination is the prefrontal cortex, right? So this is why we say adolescents, young adults are the most risk-taking population because they have all that lovely pubertal hormones like testosterone in males, which makes them want to go out and take risks, but they lack the prefrontal cortical connectivity or hardware that allows them to really assess the consequences of those risks, right?
That I'm immortal kind of.
That's right? Yeah. Like, oh, I don't need to wear a condom. I'm never going to get AIDS. I'm never going to get a woman pregnant. It's fine. It's not going to happen to me.
I can totally make this jump.
Yes.
We all can. And so the brain is continuing to develop. And the key thing is that prefrontal cortex, right? So the theory is that, okay, if you're taking substances throughout this period of brain development, you may alter the projected path, right? The connectivity, because you're altering those hedonic balances, right? And addiction is marked by the brain's kind of chronic neuroadaptations in order to revert back to a so-called normal state. So if the brain is still developing, then might you permanently alter these systems? Problem is, empirically, that's been challenging to demonstrate. And this is a large part because the brain is so plastic. So when you alter the brain during those critical neurodevelopmental periods, depending on when you're altering it, the brain will kind of bounce back, right? So, if you drink alcohol at the age of 15, is that going to permanently wire your brain? No one's really ever been able to demonstrate that. So you're seeing a lot of argument from both sides of the scientific community, and I'm here to say that it's still an ongoing debate. But I think the government and certainly a lot of scientists and medical doctors wants to be a little bit cautious. There are people that would like it to be 25, but the reality is it's
18 or 19.
18 or 19.
I recently finished Michael Pollan's book about LSD and psilocybin and, him experimenting with these things and the history of the research. And he spoke about the potential of these drugs to treat addiction like alcohol. And I wondered if you had any thoughts on that.
Yeah, I think this is actually, we live in very interesting times. Marijuana is legal, and now we're going back to the 1960s where there were some work looking at LSD, in particular the treatment of things like schizophrenia, I believe it was pegged for. And I think there's something interesting there. There's a lot of certainly anecdotal evidence that in the proper context, and I want to emphasize that. So, for example, with a guided shaman or somebody who is trained to engage in psychedelic and enhanced therapy, that individuals who may experience psychological blocks that they can't seem to get over, particularly traumatic episodes, which often are self-medicated with substances, that when they take these hallucinogenic agents, that people will feel like their mind, it's like that mind expansion, right? Good old Timothy Leary, right? So another dimension. And so they feel a little more open to the therapeutic intervention, and people will report, and particularly after, low dose psilocybin, and then also potentially LSD, and then ayahuasca, which is the brew that is indigenous to parts of Peru. People will report they kind of feel purged and kind of blank slate, start again. And certainly Dr. Gabor Mate, who I spoke of earlier, had been trying to run some of these trials in Vancouver, and before he was told that, hey, guess what? They're illegal substances. So there's something anecdotal there. I am really interested to know what's happening in the brain, right? So as a neuroscientist, I think if there is a psychological phenomenon, it must be matched by an underlying neural change. And what I think is happening, and no one's demonstrated this, so maybe if somehow it's the year 2030 and somebody's listening to this and they're like, oh man, she had the idea, then please credit me posthumously if I'm dead. Anyway, so what I think is happening is that when you take these substances, there's some evidence that it activates brain growth factors, such as brain-derived neurotrophic factor or nerve growth factor or vesicular endothelial growth factor. These growth factors aid in the remodeling of the brain, right? So remember, the brain is highly plastic. The plasticity is the learning, it's the adaptability, right? So I can imagine if you're, again, in the appropriate context where somebody's trying to work with you to re-envisage that traumatic episode, to not have the emotional trauma associated with it, and then you're taking these substances that are promoting rapid proliferation of the remodeling of the brain, then it's almost like you're pressing Control-Alt-Delete and having it happen very quickly, as opposed to what would happen over potentially years of therapy or years of pharmacotherapy as well. So that's what I think there's something there. I think we definitely should be studying this more, and there are more people studying it. So.
Getting more and more approval.
Yeah. Mm-hmm.
Do we need to give background on what Control-Alt-Delete is for the people in 2030? They'll have something else. It's like, what? It's like Propeller L F5 now. I don't even know.
Was that a TV show?
Yeah.
Before we finish up, Kim, is there any other thoughts you wanted to share about the neuroscience of addiction?
Sure. I think I always like talking about the behavioral addictions, because certainly when I started my as a graduate student studying addiction 15 years ago, the dominant thinking was that behaviors could not be addictive, and we're kind of shifting that mentality a lot. And I think it's important to mention that certainly when you think about behavioral addictions, and the ones that are more commonly agreed on are things like binge eating disorder, which can be conceptualized as an addiction, compulsive sexual behavior, gambling, and now we're looking to inclusion of gaming disorder, which is people who spend massive amounts of time on internet gaming. It's important to realize that, let's take food, for example, binge eating disorder. Somebody will not develop an addiction to broccoli or, poor broccoli, it's getting trod on today, broccoli or bread or peaches, right? The kinds of foods that are consumed by people with binge eating disorder are high fat, high salt, high sugar content, right? So the kind of analogy I make is that the behaviors that are becoming addictive in our society today are those that are engaging with stimuli that would not have been recognized by our ancestors. And that the analogy holds for addictive substances. So when you look at cocaine, well, it comes from the cocoa plant, which was chewed by indigenous populations in parts of South and Central America. Opium comes from the poppy plant, which we know would made poppy tea. What we've done as a society, as humans, we've taken that plant and we've refined it and refined it and refined it and made it so that we're not eating it, which is slowing the absorption, a very dilute version of it. We're taking the most purest form, we're removing the hydrogen bonds, and we're making it so that it's instantly absorbed. And the same thing can be said about food, in that we've taken food and we've taken meat from a cow and we've refined it and added nitrates and saturated fats and so on and so forth. And so we're very good as humans at discovering and innovating around things that are going to target that pleasure center, right? And then let's look at sex, what's happening with sex and pornography.
Supernormal stimuli.
Supernormal stimuli, yeah. Remember that? Yeah. So I think this is something that we need to be mindful of when we engage with stimuli, and particularly these machines that are in front of us, and how amazing they can be. We need to be cautious of what then is the consequence of their amazingness.
So are there behaviors that a person should look out for to see if they're getting a behavior that's starting to become addictive, or if there's people around them that are getting behaviors that are addictive?
So I always say the red flags: are you using alone? Are you engaging alone? And are you using or engaging in it to relieve poor mood or anxiety? Right?
Now, if you're listening to this podcast because you're bored, she doesn't mean that. If you're listening to other podcasts because you're bored, she exactly means that. It's probably not healthy. Except for minding the brain.
If you're addicted to the reality check, it's all good. It's all good, right?
Yeah. Learning is a positive influence in your life.
Yeah.
Our guest today has been Kim Hellemans of Carleton University. Kim, if people want to learn more about what you do and what you're up to, where can they look you up?
Well, you can find our podcast information on mindingthebrainpodcast.com. If you want to know about my academic work, you can just go to carletonuniversity.ca/neuroscience, and there I am.
Thank you.
Thank you.
It's been a pleasure.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at @TRC_podcast.